Okay, so one of the things I would definitely like to discuss uh, in this chapter is um, something about the quadratic equations. Now, look, suppose we have a quadratic equation like ax square plus bx plus c. Now, we all know that what is discriminant, right? So, what is discriminant of this quadratic? It is b square minus 4ac. Now, by Sridharacharya we know, or by the quadratic equation we know that it is x is basically minus b plus minus square root d divided by 2a. Now, suppose this d is negative. This d is negative, that is our discriminant is negative. If this d is negative, then what happens is this entire whatever x will be unreal, right? We will have unreal roots. This is something that you already know from class 10, I believe, or class 9 probably. So, if d is negative, then we will have unreal roots. So, um, for example, d is negative, the curve will be something like this. Or the curve can be something like this as well. Either it will be a smiling curve or it will be a sad curve, right? Like it looks like a sad curve, right? So it will be a smiling curve or a sad curve. In both these cases, our d's are negative. Huh. But in this case, since this is a smiling curve, our a will be positive, and this is a negative curve, so our a will be negative. Look, what I mean is, if d is equal to 0, then our curve actually it goes passing through exactly one point on the x-axis. If d is 0, it can also go through like this. This is also doable, but here a is negative. A is negative, A is positive. D is 0, and here is A is negative, D is also 0. In both these cases, D's are 0, but in this case, A is negative, and this case, A is positive. Whenever you see a smiling curve, A is positive. Whenever you see a sad curve, A is negative. We already know this, I guess. Now, if D is positive, what happens is, if D is positive, then our curve goes through 2 points, exactly 2 points on the x-axis. So here we have 2 points. The curve can also go like this. Here D is positive, here also D is positive, but here A is negative since it is a sad curve, and here A is positive. So here D is negative, here also D is negative, but A is negative as well. But here D is negative and A is positive. So these are the few of the cases that I would like to discuss before moving into the next sum. So yeah, now another thing I should have discussed, that is, suppose our curve is something like this, right? So A is negative here and D is also negative. Why D is negative? Because we have no roots, no real roots. So D is negative, and it is A is also negative since it is A is negative since it is a sad curve. Okay. So now look, one of the things that wherever all the unreal roots, whatever the solution will be, the value of y will always be negative here. Y is always negative. Why is y negative? Because this curve is below the x-axis. Since this curve is lying below the x-axis, so y is always negative here. But had the curve been something like this, D is definitely negative, A is also negative, but Y is positive. Oh no, A is positive. But Y is also positive. Why Y is positive here? Because this curve, this is a smiling curve, that is true, but it is on the positive side of, this is above the x-axis. So this is Y, here Y will be positive. Suppose a curve is something like this. Look, if a curve is something like this, then it definitely crosses, it intersects the x-axis, right? Since it intersects the x-axis, it is having some real roots. So we can see that real roots exist here. Real roots exist. Real roots exist means d should be positive. So since we have two real roots, so d should be positive, and a should also be positive. So d is positive here, a is also positive. And what about y here? Look, here y is positive, also negative. Why? Because this curve is not lying only in one region, above the x-axis or below the x-axis. This curve is, it is spanning through both the regions. It is also in the positive y-axis region. It is also below the x-axis, that is also, it is in the negative y-axis region. So we cannot say that y is positive or negative. We cannot say something like that. Okay, so we cannot make any judgment about y here. But here you see we have no real roots. No real roots. Since we have no real roots, hence we can say that d is negative. Here also no real roots. No real roots. Why no real roots? We can say, why are we saying that it has no real roots? Because it is not touching any of the x-axis, right? Had it, if it was touching the x-axis, we would have said that yes, there is one real root or two real roots. How many maximum real roots could be there? Two, right? Why? Because this is a quadratic equation. In a quadratic equation, you can have at most two real roots. Okay, so no real root, so d is negative. So that is why, see, it will lie in such a way that it will not touch or intersect the x-axis, and that is the reason it remains entirely in one of the regions. Either it remains completely above the x-axis or below the x-axis. Okay, and that is why this here y is always negative and here y is always positive. So this this understanding is very important for our next sum. So that is why I have discussed it. And so now let's just move into the next sum and we can understand it, I guess. Okay, so suppose for instance, fxb, let fx is kx cube minus 9x squared minus 9kx squared, sorry, kx cube minus 9kx squared plus 9x plus 3. Suppose this is fx. So we have to again show that where is it increasing, where is this function increasing and where is this function decreasing. Means we have to discuss the intervals in which this function is increasing and decreasing. So the first thing that we do is we find the first order derivative. So here, so wherever it will be increasing, this thing should be positive. It means 3kx squared minus 18kx plus 9 should be positive. Now look, this is a quadratic equation. So a quadratic equation is positive. A quadratic equation is positive. It means that the quadratic equation should be a smiling curve and it should be like this, right? It cannot be a sad curve, right? Because had it been a sad curve, it will definitely cross the x-axis. So it has to be a smiling curve and it will look something like this, or maybe it can also look like this. I don't know where exactly it will be, but it will definitely not cross the x-axis. It will not touch the x-axis. Why? How can I say that it will not touch the x-axis? How am I sure? I'm sure because if it touches the x-axis, then y will be 0 there, right? But we are having a quadratic which is always positive, so that this y must be floating above the x-axis. So this is the reason why it should be smiling. Okay, so in a smiling one, we know that d is 0, less than 0, and we also know that since it is smiling, a should be positive. So since this is positive, so this is our curve. This is how our curve should look like. Okay. Also, we can say that our d, that is our discriminant, should be negative and our a should also be positive. So we can say that what is our A here? What is ABC here? A is 3k, B is minus 18k, and C is 9. So we can say that A is positive, the 3k must be positive, and we will say that our D is negative. These are the two things that we can definitely say. Since this is positive, we can say that these two will definitely happen. Okay, I want you to understand this part. This is the only important part in this one. If you can understand this one, everything is done. Okay. So K is basically, K will be if 3k is positive, then it means K is also positive. It means our K is also positive. Okay. Now what about D is less than 0? So D is less than 0 means B square minus 4AC is less than 0. B square minus 4AC means minus 18k whole square minus 4 into 3k into 9 is less than 0. This means what? So 18 square. I don't know what 18 square is. Let it be 18 square. 18k square. 18 square is k square. Let it simply be 18 square k square. Minus will not remain because minus gets squared, it becomes positive. And here it becomes what? It becomes 12 into 9. So it becomes 12 into 9. We can say it becomes basically 6 into 18k. Because 4 into 3 is 12. So it is 12 into 9. We can say this same 12 into 9 as this. So we can say it is 6 into 18k. Okay. Now we are dividing entire by 18. So we get 18k square minus 6k is negative. So we can say, if we can just have it factorized, we will get 3k minus 1 is negative. Now we already know that k is positive, so 6k will always be positive. This means this must be negative. Look, since we know k is positive, this means that 6k is also positive. Now if this entire thing is positive and 6k is also already positive, then this must be, no, this entire thing is negative, right? And this thing is positive, so this must be negative. This means we are left with, this is negative. So finally we have the value of 3k must be less than 1. This means k's value must be less than 1/3. This means we are finding two things. Okay. First of all, k must be positive, and the next thing is k must be less than 1/3. So the value of k must be in this interval 0 to 1/3. Okay. So yeah, they were asking for the value of k. So the value of k is 0 to 1/3. If this is actually in the question, they have already said that this is an increasing function, and for this increasing function you have to find the value of k. So yeah, so that's the sum.